All right, going to look at a short example of a continuously compounded interest problem. Um, for continuously compounded interest, the interest is applied all the time, and there's a little bit of calculus behind the scenes where this PERT equation, A equals PE to the RT, uh, some limits and that kind of stuff where this comes up from. Um, for the most part, the players are the same. The amount is A, that's the final dollar amount. P is your principal, that's your starting amount, dollar amount. R is your interest rate as a decimal. Time is T based off a year, and it's all based off a year. And E is 2.71, that's the base of the natural logarithm, and just use the E in your calculator. Let's do example real similar to the one with the compound interest problem. So we want to know how much should be invested to obtain 30,000 at 7% interest, compounded continuously. So that's the key word we're looking for, is the word continuously, and in 20 years. And so what we'll do is we'll just kind of write down the things we know. So we know amount, we know rate, we know time, and we do not know principal. So we're going to plug those things in, and we'll go ahead and solve for the principal. So plugging stuff in, and really the only thing to work out here is that exponent on the top there, so we'll work that out. And then that e to the 1.4 is attached by multiplication, so we're going to divide. And so we get a little bit less than the previous example with compound interest, and that's because the interest is applied all the time, so we get a little bit more interest worked in there. How I would enter that into my calculator: 30,000 divided by e, caret, and 1.4. Some calculators, when you hit the E button, it'll give you that already.